Fraud detection using machine learning. The exponential rise in digital payment platforms has been accompanied by a surge in financial fraud instances. This underscores the urgency for a robust fraud detection system capable of precisely identifying the fraudulent transaction without triggering the unnecessary alarms. A critical concern pertains to the inherent imbalance within the fraud dataset, necessitating strategy to counter the skewed class distribution. Our focus lies in tackling this challenge using the machine learning methodology. Our objective is to implement the diverse binary classification strategy across a labeled dataset encompassing the payment transaction. Through this project, we intend to comprehensively evaluate the efficiency of these approaches in accurately detecting the fraudulent activities, thereby contributing to the enhancement of security measures in the realm of digital transactions. And the application of this diverse machine learning methodology, including logistic regression, support vector mission, decision tree, and many more, is explored to identify the fraudulent transaction within the payment system through the analysis of a labeled dataset. The central aim is to substantiate the efficacy of these techniques in accurately detecting the fraud while maintaining a low false positive rate. The investigation delved into the complexities posed by imbalanced dataset in the fraud detection and offered the remedy to enhance the precision of the classification. Moreover, thus advocate the integration of advanced algorithms like decision tree and convolutional neural network to bolster the existing technique. The potential of leveraging the time series nature of the dataset is highlighted, demonstrating a comprehensive approach to refining the fraud detection mechanism and bolstering the security of the payment system. And these are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7, Anaconda with version of 3.7, or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the packages. In this step, we need to import the necessary libraries and packages such as sklearn, cburn, matplotlib, and the relevant tool for the data processing, visualization, and the model building. And the second step is exploring the dataset. The dataset containing the transaction data is explored to understand its structure, variable, and the statistical distribution, providing the insight into the nature of the data. And the next step is data processing. Data pre-processing techniques are applied to handle the missing value, outliers, and the inconsistencies, ensure the data quality and the reliability. And the next step is visualization using the cburn and the matplotlib. cburn and the matplotlib libraries are utilized to create the visualization, aiding in understanding the data pattern, trend, and the potential correlation. And the next step is label processing. Labels indicating the fraudulent or the legitimate transactions are processed, encoding them for the compatibility with the machine learning algorithm. And the next step is feature selection. Relevant features are selected based on the significance and the contribution to the prediction task. This step reduces the dimensionality and improves the model performance. And the next step is data splitting to the train and the test. The data set is divided into the training and the testing set, facilitating the model training on the one subset and evaluation on the other. And the next one is more building the model. Here various models are built. The first one is linear SVC. It constructs a linear decision boundary for the classification. It's applicable when the data has a clear linear separation between the classes. In this project, it offers a baseline for the classification accuracy. Its effectiveness be limited its data to be of linearly separable. And the next one is SVC with the RPF kernel. Support vector classifier with radial basis function kernel is handling the nonlinear data by transforming it into the higher dimensions. In the fraud detection, it captured the complex relationship among the feature, enhancing the model ability to detect the intricate fraud pattern. And the next one is logistic regression. Logistic regression estimates the probability of the class membership. It's effective when the data has clear decision boundary. In this project, it provides the interpretable insight into the feature importance and the relationship, aiding in understanding the fraud indicators. And the next one is random forest. It is an ensemble of decision tree. It handles the complex data relationship, reducing the overfitting and captures the feature importance. In the fraud detection, it excels in captivating the diverse pattern of the fraudulent activities. And the next step is decision tree. It offers a simple, interpretable decision-making structure. It be prone to overfitting. It reveals the clear decision path in the fraud case, making it valuable for understanding the criteria leading to the fraud identification. And the next step is naive-Bayes. Naive-Bayes is probabilistic and assumes the feature independence. It's efficient for the high-dimensional data. In the fraud detection, its simplicity not only captures the complex interdependencies but also serve as a quick initial model. And the next one is stacking classifier. It combines the models hierarchically, leveraging the strength, integrating the random forest, SVM, and the logistic regression, offer a balanced approach to detect the fraud, benefiting from the individual advantages. And the next one is voting classifier. It aggregates the predictions from the multiple models, combining the random forest, passive-aggressive classifier, and the boosting, enhance the overall prediction accuracy by considering the perspective and balancing strength. And the next step is user gives the input. Here we build a class is a web interface where the user provides the input data to it. And the next step is the given input is pre-processed for prediction. The input data undergoes pre-processing similar to the trained data, ensuring it is suitable to the format of the model. And the next one is trained model is used for the prediction. The pre-processed input data is fed into the trained model for the prediction. The model evaluates the input and makes the prediction about its classification. And the next step is final outcome is displayed. The outcome from the various models are presented to the user, showcasing the prediction made by with the help of the class as a web interface. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it. The static folder containing of the folders like CSS, JavaScript, images, fonts within it. And the template folder containing of the HTML documents. It typically include form, index, result, sign-in, sign-up pages within it. An app is an py file which contains the information related to the front-end logic. It includes the code written in Python that handles the server-side operation, such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the model is a SAV file which contains the combination of the algorithms and loaded into the project code during the runtime to utilize the trained model for the various tasks. And these are the datasets that are processed after the pre-processing. And the signup.db is a file appear to be the database file that uses to store the user information. And the notebook.ipynb file contains the combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command that is cd space and copies this code folder path. By this, it will change the current directory to the code folder's path and then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or logical issues. And then click on the enter button. After running this app.py file, the Flash framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I am pasting this link and then click on the enter button. Here we redirect it to this page containing of some information and the title of the project. And then click on the sign up button. Here it will redirect to the sign up page containing of some necessary details that need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it will redirect to the sign in page containing of the username and password that don't need to be filled, and then click on the login button. Here it will redirect you to this page containing of the some input details that are need to be filled, and I am entering those details as of Enter the step. I'm entering the step as 1 and choose the type as of payment and enter the amount is of 9839.64 and the old balance is of 170136 and the new balance is of 160296.36 and the old balance is of 0 and the new balance is of 0 and is flagged as fraud or no as of 0. So I'm choosing the no and then click on the predict button. Here I predicted the financial transaction is non-fraud based on the input given, and by clicking on the home button here we redirected to this page and we can re-enter the other details here, and I'm entering the details. Enter the step as of 19 and the type is of cash out and the amount is of 13030 and 0 and the old balance is of same 1 and the new balance is of 0 and the old balance destination is of 54044326.62 and the new balance is of 10432417.9 and is flagged as fraud as, and then click on the predict button. Here I predicted the result as of the fraud based on the input given. In this way we can detect the fraud using various machine learning algorithms. And in conclusion, the effectiveness of the proposed machine learning technique in detecting the fraud transaction and the dataset called BASEM with high accuracy and low false positive, especially for the transfer transaction. We suggest the further improvement to the technique by leveraging the categorical features and the time series property of the dataset and creating the user-specific model based on the previous transactional behavior. To emphasize the importance of balancing the correctly detecting fraudulent sample and not misclassifying the non-fraud sample in the fraud detection, and propose a class-weight based approach to address this issue.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.